In this lecture, we are going to discuss a little bit about the hardware platform and design in Internet of Things. So, as we have discussed in the previous lectures as well, IoT hardware basically has an embedded system or a microcontroller, and you add some communicating protocols to that hardware so it can interact and interface with other devices, right? So there are a lot of platforms available nowadays. So I'm discussing some of the most commonly used platforms that you can also use or anyone can use for developing IoT products. So the first one is Raspberry Pi. So it's like a small computer. It has an ARM processor and it also runs on a Unix or Linux based OS. So you can use Raspberry Pi to develop good IoT applications, even complex IoT applications. Then a very simple device, Arduino. We have had it since a long time. So Arduino is basically a microcontroller. It's a board with a microcontroller embedded in it. So of course it's an ordinary microcontroller or a board, but we require some additional hardware so that it becomes IoT compliant. We can use some Wi-Fi modules or Bluetooth modules, NFC modules or RF modules, and we can interface with Arduino and make IoT products using that or prototypes. Alright, but standalone Arduino does not have any property that can enable it to be used for IoT. Next, there's another company that's called Particle. So it also develops hardware platforms and associated software tools for developing IoT prototypes and products. So if you go to the site or you directly Google Particle IoT, you will get a lot of information about this company. It has a lot of products ranging from beginner to advanced. So depending on the type of IoT application you're trying to implement, one of these platforms can be used. Then there is another BeagleBone platform that is actually manufactured by Intel, and it can also be used for developing IoT prototypes and products. So this is a little bit advanced machine, advanced in the sense it's not exactly a microcontroller along with some additional communication protocol. It has a good amount of memory. As you can see in this board, there are a lot of other peripherals also available as well. So this can be used for intermediate to advanced IoT applications. But we don't only have to rely on these hardware. We don't always have to purchase. So as we have discussed, any microcontroller or any embedded board that you are already using for writing applications for embedded systems, you can always convert it into a hardware that can be used for developing IoT applications. So how can we do that? Take any microcontroller or any board like we did with Arduino, and we can use RF, NFC, Bluetooth, Wi-Fi or Ethernet modules so that that board or microcontroller can be used as an IoT platform. So here I'll be showing you how we can convert our MSP430 normal microcontroller, how we can convert it into an IoT compatible platform. Alright, so of course to convert it into IoT platform we require one of these protocols, right? So again in the market there are a lot of such devices available. ESP8266 is one of the Wi-Fi enabled devices that you can attach to your microcontroller so it gets the Wi-Fi capability. Then Bluetooth HC05 is very commonly used with microcontrollers. So here we are going to discuss a booster pack which is actually manufactured by Texas Instruments only, since MSP430 is Texas based. So I'm also discussing a booster pack that's called CC3100, manufactured by the same company. Alright, of course other than this you can also use any of the other protocols or peripherals or devices to convert the MSP430 into an IoT platform. So let us look at some of the features of this booster pack and add-on. So it has a dedicated ARM microcontroller unit which executes Wi-Fi and internet protocols. It has some ROM. It stores pre-programmed Wi-Fi driver and multiple internet protocols. It has a TCP/IP stack which supports communication with computer systems on the internet. So this is the protocol with which it is going to communicate. It has a crypto engine also which provides fast and secure Wi-Fi connection as well as internet connectivity. So this is also important. So this is not available in many of the devices that are available in the market. It has a 802.1 B/G/N radio baseband and medium access control. So this is your Wi-Fi radio that's attached in this so that it can wirelessly communicate with the internet or any other router or network. Then it has a SPI or UART interface that connects this module to the host microcontroller unit. Now this is a very important point. No matter which kind of external hardware you are using to convert your normal microcontroller into IoT compatible platform, because this is how you are going to interface your microcontroller with that particular device. So in the market, like if we talk about ESP8266 and HC05, they are UART based. So we can use RX and TX pins to connect them with the microcontroller. However, CC3100, it has UART interface also and SPI interface as well. So this is actually a very good example of SPI interfacing of the microcontroller with some other device or peripheral. So let us look at the interfacing here, and this is how you can also do it practically. You can take your MSP430 board, maybe you can take your F5529 microcontroller or F5529 board, and you can make these connections with the CC3100 booster pack so that your existing microcontroller, that is the MSP430, it will have Wi-Fi capabilities. So it can connect to the internet or it can be a part of any local network. Right? Standalone, it does not have any Wi-Fi capabilities or any wireless communication protocol capabilities. So if you remember, SPI is basically a 4-pin protocol. So you can see here MCU is going to be the master here and the slave is CC3100, because the microcontroller is going to be controlling and dictating everything. So the first pin, that is the SPI clock, it is connected to the CC3100 clock. So that is obvious, and the direction is from controller to the slave because the master always gives the clock. Then there is a chip select. This chip select can be used or any other GPIO can be used, as we have seen in unit 1 lectures as well. So here we are using the microcontroller, that is the master's chip select, to connect to the slave's chip select, so that this particular slave is being used using SPI communication. Then we have the other two pins, that is MISO and MOSI. So we can see the master in slave out, it is in this direction from the slave to the master, right? And then finally the master out, slave in, it is from master to the slave. Then we have another pin called the interrupt pin. So this can be used for interrupting the microcontroller depending on if the slave, that is the CC3100, needs some attention or it has finished some work. So accordingly it can interrupt the microcontroller. Then we have another pin, NHIB. So as you can see, it is connected to the microcontroller's GPIO, right, from the master, that is the microcontroller, to the slave. So this is an additional pin that has nothing to do with the communication, but this pin can be used for putting this 3100 in a bootloader mode where you can flash or update the firmware of CC3100. That's it. So this is how you connect any microcontroller to some add-on module or peripheral that grants it Wi-Fi capabilities or Bluetooth capabilities. It can be anything. So you only have to take care about the kind of interfacing you are going to be doing. That is whether it is a UART based, SPI based or I2C based. There are several products, several devices available in the market that can be used and which have different interfacing options available so that your existing microcontroller can become IoT compatible.